So welcome everyone. Thank you for joining us for today's webinar. I'm Cheryl. I'm a community manager at Xperfy. So Xperfy is the sponsor for this event. But before we get started, just a little housekeeping for everyone. If you have any questions, feel free to send them in the chat box of the. You can find it on the Q&A section of your Zoom control panel. We would love to hear your thoughts and your questions, so feel free to send them in, and we will get back to them by the end of the presentation. So the webinar is sponsored by Xperfy, a Harvard incubated company working on the intersection of future of work and AI. Xperfy is on a mission to help freelancers and consultants get exclusive access to remote projects and job opportunities with Fortune 500s, top consulting firms, and fast-growing companies. So we can get started. I will just introduce the topic, and then I will introduce our speaker for today. The field of data science and AI had tremendous success even before the COVID pandemic turned it all upside down. As discussions about the shape of recovery and the future of work are still evolving, you may wonder how careers and opportunities in the field of data science and AI may advance post-pandemic. So we have invited Professor Reza Mousavi, Assistant Professor at the University of Virginia, to provide his unique perspective on the future of AI jobs and how to stay relevant in a remote economy. This perspective would also be helpful for hiring managers as well, especially from the perspective of understanding the AI job landscape. It is with great esteem that I introduce you to our speaker, Professor Reza Mousavi, Assistant Professor at the University of Virginia, where he has been teaching advanced AI and business analytics and research methods courses. His work has been published in a variety of elite academic journals and has been presented at international and national conferences. In addition to his academic work, he worked as an AI and data science expert with several Fortune 500 companies and consulting firms such as Deloitte, PwC, and State Farm. Now, without further ado, I will turn the time over to Professor Mousavi.
Well, thank you, Cheryl. Well, thanks so much for having me today. Hello and welcome, everyone. So hopefully you will find this webinar a good one. We'll take home some thoughts. So a little bit of information about our agenda for today. So I'm planning to talk a little bit about the difference between data science projects and AI applications. I think that's a key thing here to clarify. And then we will talk about AI maturity models. And we see a little bit of stats about where the money is flowing into these days and how AI is going to be related to automation in future. Later on, we're going to talk a little bit about career prospects for AI experts and data scientists. So we're going to talk a little bit about some of the positive things that could move this market and some of the potentially concerning things we should be aware of. And at the end, we will have a few recommendations. All right, so let's move on to our background. All right, so before we get into the conversation, let's just talk a little bit about the journey of data within a business process. So typically, we start from the left when we have a source of data. It could be our website, it could be some social media websites, it could be some flat files laying out somewhere. We usually pull these data sets and put them together in data warehouses. And then from those data warehouses, we extract some specific parts of the data and put them into data marts or data tables. And then data scientists or AI experts would be able to process and analyze these data sets and then extract some insights. So in this journey, what happens at the end is the result of this project, it would be some type of a report. It could be a formal report, it could be an informal report given to the decision makers within firms, or it could be some type of dashboard that would actually help analysts from other divisions or business units to basically understand their data better or like extract some knowledge from the data, or it could actually turn into some type of application that would run without human intervention or with minimal human intervention. So that's what we call AI applications. So the applications are based on data science projects, and they would not require a whole lot of intervention by human or the workforce, basically. So if we see this as an example, we can talk about, let's say, the autopilot system. So the autopilot system, it started with a series of data science projects. It could be projects in computer vision, for instance. Can we detect these objects without human intervention? And then those types of projects are pulled together into a single application that we call autopilot. So if we actually move to the next slide, we'll see that there are some overlaps between data science projects and AI applications, but they do have their distinct flavors. So the way I define it is that typically most of the projects are being started as a data science project, and then some of those will turn into some type of AI application, right? Does that make sense? Sometimes we do need to use big data technologies, depending on the scale of the data or the way the data is going to be used. So I thought this Venn diagram is going to help us a little bit understand the differences between data science and artificial intelligence, how they actually relate to each other and such. All right, so let's move on. All right, so in terms of artificial intelligence market, so I'm actually talking about artificial intelligence marketplace because data science is very broad. So it's really, really hard to see firms or companies not using any type of data science work. But artificial intelligence is a bit more specific because it's more tangible. It's some type of application that could run without human intervention. So that's why I'm actually looking into artificial intelligence marketplace. And that's where basically the future is going to be, because ultimately most of these data science projects would turn into some automated application. I think that's where the business value is. If we take a look at the market share of artificial intelligence application, you see that most of the money is basically being spent on customer service or sales, or threat intelligence, or fraud detection. So those are basically the main markets for artificial intelligence. And the reasons would be that, well, if you think about chatbots, for instance, it's fairly easy to build a chatbot that would be able to answer typical questions that customers would ask from us, right? So you see that many of the banks, many utility companies are actually using these chatbots. So those are AI applications. But if you think about how they evolved into that application, is that they usually started as a data science project. It could be a natural language processing project. It could be a computer vision project. But ultimately, they turn into these types of automated applications. So that's where most of the money has been spent so far. And actually, the other sector would actually benefit from artificial intelligence in future is predicted to be healthcare. So healthcare is quite inefficient when compared to other sectors. And a lot of firms are actually thinking about offering products and services specific to healthcare industry. The other thing that is really important for healthcare these days is that shift from traditional models to a value-based model. So right now, authorities are basically trying to push providers to adopt this value-based model for healthcare, and that would require a lot of information sharing, data sharing, things like that, which is going to be really good for data scientists. Basically take those data sets and build some AI applications with. All right, so let's move on to the next slide, please. All right, so in terms of the projection for spending money on AI. Again, the trends would be customer service. Trends could be sales. Those are the major sectors we would actually see the growth in. And then anything that would be something that we can automate. So that would be another use case. Overall, the projections are pretty positive. So you're going to see more and more AI-based applications being used in routine business processes. All right, so if we can move on. All right, so now for us to be able to say what are the career prospects for AI and data science experts, kind of need to put some type of framework and take a look at that framework and understand where we are in terms of using or adopting these types of technologies. So MIT actually published this model a few years ago. It's called Analytics Maturity Model. And what they essentially said is that we can divide or categorize organizations with respect to AI maturity to 3 different buckets. So the first one, if I start from the left, is going to be what we call analytically challenged organizations. So these are organizations that use analytics and data science to some extent, but they don't have a master plan for benefiting from the data they have been collecting. They don't even know what kind of data they're collecting, and they don't know how to basically turn that data into some useful insights. So those are companies we call analytically challenged companies. The next one is basically what we call analytical practitioners. So most of the Fortune 500 companies will actually fall in this bucket. So we have data science teams in these companies. They are aware of the data sets they're collecting. They're aware of the data quality issues they may have. They're trying to resolve those. They're trying to build better pipelines for their data science projects and things like that. But when it comes to making ultimate decisions, there is still some type of tension between managerial decision making and database decision making. So ultimately, some of the decisions are not driven by the data. It could be based on managerial insights. Finally, we have analytical innovators. So these are companies that have been using data science and AI for quite some time now. And these are the companies that exactly know what type of data they're collecting, how to turn the data into profit. And they are basically providing analytics-based offerings. So you can think of high-tech companies such as Google, Amazon, Facebook. A lot of other companies actually fall in this category. Those are the ones that actually provide different offerings based on analytics and artificial intelligence. On the right side, you see different types of analytics. So we can very broadly define or divide all of the analytical works into 3 buckets as well. So the first one is what we call descriptive analytics. The second one is what we call predictive analytics. And the third one is what we call prescriptive analytics. So I'm going to provide very brief descriptions of these 3 types of analytics. The first one is descriptive. It basically means that we want to summarize our data sets into some digestible sentences. So for instance, we pull the data about our cells in different areas or regions and then basically summarize them into digestible pieces of information. So this is what we call descriptive analytics. Predictive analytics is one step beyond that. So not only we are describing the data, but we are also able to predict, based on the historical trends that we have seen so far, what would actually happen in the future. So we are trying to forecast, let's say, our future sales, or trying to forecast if this online lead is going to turn into a customer and things like that. So that's what we call predictive analytics. And then ultimately we have prescriptive analytics. So this is basically the top of the line in terms of analytics. So this is when we are not only finding what is going on in our organization and with our customers, and not only we can make predictions about the future, but we can learn things from what we have seen so far, and we can change the future based on that. We can basically make some modifications in our routine business processes to improve the prospects into the future. So that's what we call prescriptive analytics. So prescriptive analytics is about, why something happened, how we can improve that, and things like this. So those are kind of answers we can get from this type of analytics. All right, so we're going to run a quick poll. We're going to get some information from you. There are two questions in the poll. The first one is, based on the MIT's model we just discussed, where do you think your organization is? Is it an analytically challenged company, or is it a practitioner, or is it an innovator? And this could be actually, when I ask my students about this question, I get different responses. So sometimes they say, my department or my business unit is innovator, but the company as a whole is a practitioner. So in large companies, you'll actually see that. But if you're working for a smaller company, probably you can answer this question based on the overall company. But if you're working for a bigger company, you can actually answer the question based on the business unit or department you're working at. The second question I have for you is, what type of analytics, descriptives, predictive, or prescriptive analytics you're mostly involved with these days? All right, so we're going to have a few moments here so that we can collect your responses. And we can probably move on to the next slide as well. All right, so as you are providing your answers, I'm going to talk about one of the very well-known models in innovation. So it's called Rogers' diffusion of innovation. So whenever there is a new technology coming in, we have some innovators. So those are the ones who came up with that technology or innovative idea. We do have early adopters, and then we have majority adopters, and then we will have, at the end, we will have the laggards. So it's kind of like a bell curve that you can see here. So it starts with a small percentage of population of firms are going to use that technology first, and then eventually it will become more mainstream. And then at the end, we'll have all of the other sectors that haven't been using that technology eventually will adopt that type of technology. So this is what we call Rogers' diffusion of innovation. So Cheryl, if you could share the poll results with me, and then we can move on to the next slide. Okay, perfect. All right, so that's pretty good results. So what we are seeing here is 41% of the respondents said their company is analytical practitioner, 35% said innovators, and then 24% challenged. In terms of what type of analytics you're using in your organizations, 47% said descriptive analytics, 41% predictive analytics, and then 12% prescriptive analytics. So this is really, really interesting, really good. So if we move on to the next slide, I'm going to talk about Rogers' diffusion of innovation model for data science projects. Many of the projects qualify as a data science project because they use some type of data science methodology. Data science methodologies are quite broad. So it could come from stats, it could come from computer science, it could come from econ. So if we have any of those in our projects, it could be perceived as a data science project. As you saw in the poll, majority of you are actually using descriptive analytics. So that kind of basically puts us somewhere around here. So if I can make some annotations here, I will actually do this. So it would put us, with respect to using data science in our organization, we should be somewhere around here. So we're kind of in the middle. Like, this is basically the range that we are seeing based on the responses. And then if we move to the next slide, so I'm going to clear this. Now, if we take a look at the same model, but with respect to artificial intelligence instead of data science. So remember, when we're differentiating data science and artificial intelligence, we said that artificial intelligence is the realization of data science into some type of automated application. So that's a bit more challenging to do, right? And based on the types of analytics that we do, it does sound like we are somewhere around here. So we're basically using some type of predictive analytics, mostly descriptive analytics, but very small percentage of us are basically using prescriptive analytics, which is a key ingredient of artificial intelligence. So I would basically say, based on the response that I've been getting in different venues, we are around here in terms of artificial intelligence. All right. So if you can go to the next slide, please. And I am going to clear this. All right. So with this in mind, what we're saying is the majority of the companies were innovators and early adopters of data science. They are turning into innovators of, let's say, AI. And then the ones who are in the majority adopters, they're going to basically join these adopters later on when it comes to AI. So based on that, if you can actually go to the next slide, we can actually take a look at this, the prospects of automation for different types of jobs. So I'm gonna, Cheryl, if you could click on that link and then open the page. I appreciate that, thank you. And then scroll down, please. So this report came out a few years ago. It's put together by Bloomberg. So on Y, on this axis, you're basically seeing the pay scale. So it's actually, you see the numbers on the right side. And then on X, you're basically seeing the likelihood of automation. So the jobs that you see on the left, those are the ones that are really hard to be automated. And the ones that you see on the right, those are the ones that are really highly possible for them to be automated. Now, if we think about data science and artificial experts, we are somewhere around actually this area. So in terms of pay scale, I mean, there's a range in pay, and there is actually some range in terms of, what type of analytical methodology we use. But here's the rule of thumb. If we are using more descriptive analytics, we are going to be on the right side of this scale. If you're using prescriptive analytics, you're going to be moving toward the left side. So your job is going to be more difficult to be automated. All right. And then also, if you're using prescriptive analytics, it could also improve the compensation as well. So I just wanted to kind of show you this one and then how it relates to the other content we just covered today. Now we can switch back to our slides. Overall, I mean, we're in pretty good shape in terms of job prospects and like the concerns that we might have in terms of automation. But there is still room for improvement in terms of the type of work that we get involved with and things like that. The good thing is for us to be able to basically get into a better situation in terms of job prospects, we see more specializations as a key element. So if you are a generalist, you probably are using descriptive analytics a lot more than prescriptive analytics. If you're specialized in a specific domain, you are probably using predictive analytics and prescriptive analytics more than descriptive analytics. So that's kind of like the general sense here. We do have a mind map here, kind of creates a taxonomy of different topics within AI and data science. So this is based on different sectors or different methodologies. For instance, here we have natural language processing, we have computer vision, we have deep learning. On this side, we basically have causal inference. So that's basically one of the things that I really, really recommend looking into. We have a statistical analysis, econometrics, a few other things. And then we have different applications of artificial intelligence and data science. So these are the ones that are quite useful in terms of being able to deploy AI type solutions. So the key thing here is that more specialization is going to be better for data scientists. So in the next slide, all right, we are going to talk about how COVID-19 influenced all this. So whatever we were talking about was the general trend even before COVID, but now how COVID-19 influenced the career prospects. One of the things that we observe right now, you may have heard that in the news, there is lower interest in lower paying jobs in service industry. So let's say restaurant chains, those kind of sectors, they really have a hard time hiring employees. So those types of jobs, if they can be automated, they can be a pretty good area for AI, because the cost of hiring employees is actually going up, and I would say if it's something that we can automate, it would make it more beneficial for the companies to actually do that. The other thing is related to healthcare. As I said before, healthcare relatively is inefficient in terms of how the transactions work, in terms of how the claims are submitted and things like that. So that's another prime area for AI. In terms of STEM professionals, we see a lot of interest in that type of job, and see more interest in managerial jobs as well. So what I'm trying to say here is that COVID-19 even accelerated the needs for AI experts and data scientists who can go into different sectors and basically fix the problems they're facing right now. So that's basically the key takeaway from this slide. So we go to the next one. All right. So the other things that we observe is related to the type of work, the work environment, and how we want to actually work, and what would be our relationship with our employers. So we see a lot more interest in remote work. We see a lot more interest in flexible work schedule. So for the employees, one of the key concerns would be productivity and novelty in their work. So we do have a working paper with a few professors and other universities. So what we observed is that because of COVID-19, people tend to work more. So we have higher productivity, let's say, so they get more things done. But if you take a look at the quality of the work, they kind of lack novelty. So the quality of work might actually degrade a little bit. So this is something kind of important for both employees and employers. So employees are basically being burnt out, and then employers could have a long-term plan for making them engaged and making sure that they basically they can return to the normal environment they had previously. So one of the things that we actually see these days is that a lot more interest in contract work. So a lot of data scientists, they will like to get involved with different types of projects in different sectors, which is really good. The other reason for some data scientists doing that is so let's say you're working for a bank or for some insurance company, or some of the other companies related to these types of sectors, but you're always dealing with the same type of data. But let's say you're interested in computer vision, or let's say you're interested in natural language processing. So you kind of get bored with those types of projects. You want to get into some more interesting, some type of different project. So that's another thing that we see in data scientists these days. They actually tend to like to work on a variety of projects of dealing with the same type of data over and over. All right. So let's move on to the next slide, please. All right. Now, what are the concerns that we might actually have if we are data scientists or AI experts? So one of the things that would actually have some type of impact is market saturation. We are hiring professors, let's say this year, hiring 3 professors. And we see that a lot of professors teach data science and business analytics, a lot of them. So that kind of tells us that the universities are training a lot of folks in this field. And that could bring in a lot more providers that we used to have previously. So that's something that we need to be aware of. So it's really good for employers, but if you want to be an employee in this domain, that's something you might be a little bit concerned. The other one is related to the paradigm of reinforcement learning. So the idea is, can we use previously used data sets, train something, and then once we build that something, can it retrain itself with minimal supervision? So that's what we call reinforcement. That's the gist of it. So one example I have here is I recently was trying to collect some data. That's actually the AWS Amazon SageMaker Ground Truth. So I was trying to collect some labeled data set for one of my projects. One of the interesting things I found there was that if you have workers on this platform, label your data set, let's say identify different objects, or like classify text into positive, neutral, or negative. When Amazon collects these labels from the workers, it could actually use that trained data set to label the rest of the data set that hasn't been seen by the workers. So that's the piece that we have here. It says assistive labeling. This part here, I'm actually going to use this arrow right here. So that's the kind of thing that we need to be aware of if you're a data scientist or AI expert. AutoML, you probably heard about that. Hugging Face is a pretty good platform for NLP related models. So there are a lot of different things going on. AWS recognition is another one. So you can easily upload a bunch of images, and then they can extract all of those images. Extract a lot of information out of those images. So you don't need to have a data scientist, let's say, in-house to be able to get fairly basic but useful information out of different types of data. So those are the kind of things we need to be aware of and keep an eye on. So let's move on to the next slide, please. All right, so some final thoughts and recommendations before we answer questions, if you have any questions for us. So the first thing I would actually say is that shift from descriptive analytics to prescriptive analytics. To be able to do that, the first thing we need to understand is the difference between association and causation. So in descriptive analytics and predictive analytics, we are dealing with associations. We're basically saying that if this variable went up, so did the other one. But we don't really know if the first variable was the cause of the second variable, right? So that would be the main thing that is needed for prescriptive analytics. So if you're trying to kind of come up with solid suggestions about improving our business processes, we need to know what kind of factors are causing our success or what kind of factors are causing our failure. So that's the key thing here. And to be able to do that, so if you take a look at the second bullet point, learn how to run online experiments. So experiments are really, really useful in supplementing our previous analytical models. So usually when I work on a project, we find a pattern in the data, we use predictive analytics, we use AI and things like that to find the patterns. But to be able to prove that what we are saying is true, we actually run some online experiments. And today, it's super, super easy to run online experiments. So you can use Qualtrics to build out your surveys, and then you can use Amazon MTurk to hire participants. So, I mean, there are like some IRB-related concerns you actually need to be familiar with before running experiments on human subjects. But overall, this is going to be a fantastic supplement to predictive analytics. That would be a great addition to what you have been doing with predictive analytics. The other thing is related to explainable AI. So these days, you might have been hearing about explainable AI a lot. So there are some packages that you can use. Shapley is one of them. Lime is another one. So these are the kind of things that we can use to answer basic questions that are related to the patterns that we observe in our different data sets. And finally, learning how to be a good storyteller. So if we can put everything together and use the insights that we extracted from the data and come up with interesting stories, that would be a pretty nice complement. Finally, prioritize the depth over the breadth. So being more specialized, it could be either specialized in a specific industry or specialized in a specific methodology or specialized in a specific type of data. Whichever it is, I think that would be a great direction. All right. I think that's pretty much it. If you have any questions, please feel free to ask. Or Cheryl, if you wanted to ask some of the questions, I would be happy to answer.
So thank you so much, Professor Mousavi, for the fruitful discussion. I'm sure everything that you have shared with us today will be helpful for everyone. So just a reminder for everyone, I did send in the chat box a copy of Professor Reza's presentation. So if you would like to take a look at it, share it with your colleagues, your friends, feel free to do so. So I would like to quickly add to what Professor Mousavi has said about platforms. So Exerfy is a platform where experts can apply to our 20 talent clouds, and they can be matched with projects from Fortune 500s and top consulting firms. So we will go ahead and take the time to answer some of your questions. So just a reminder, if you still have a few questions, you can still send them in. So I will proceed with our first question for Professor Mousavi. What role or companies would you target when searching for your first job right out of graduate school if you wanted to get the highest leverage, real-world experience in the job while continuing to grow and learn cutting-edge technology and AI? Is it just FANGM companies or other tech-related companies?
Yeah, so that's a very good question. I don't think you necessarily have to work for high-tech companies to be regarded as a good data scientist or even to grow. I think what is important is that to what extent data science is informing actual business decisions. I think that's the key thing you will probably want to look into when you are doing your interviews with different companies. So if you feel like, hey, they're doing this data science project because everyone else is doing that, but ultimately the decisions are not based on the insights generated by data scientists, you probably want to have a second thought about that type of company. But it could be a company in, I know a lot of companies in utility sector or some of the other sectors are not high tech in any ways, but they do have a pretty good data science teams. They do rely on data science work. These are just in a specific departments or divisions within those companies. I think that's what I would be looking for. The other thing is look into the other data scientists the company has and see what type of projects they have worked on. You can actually take a look at their GitHub pages and see what type of work they do and things like that. But don't take my recommendation as hey, I have to work for the innovators to be able to be a very successful data scientist. I don't think that is true.
So thank you so much for answering our participants' question. So let's move on to the second question. So how do you see the future of consulting profession in data science?
I think that it's not separate from what we discussed so far. So I would actually say again, consulting, if you are a generalist, you would be a little bit concerned. But if you're consulting, but specific to a certain methodology, you're really good at NLP or really, really good at computer vision, you can still offer your services as a consultant, but jumping from one type of project to another project without a good agenda, I think that would be something a little bit concerning.
Thank you so much. So moving on to our third question. What are your thoughts on the role of cryptocurrency on data science, specifically in terms of things like on-chain analysis, especially as different economies adopt to using blockchain technologies?
So that's a big question. I'm educating myself on this topic. So from my understanding, the technology, the blockchain technology, that is going to stay regardless of crypto. But crypto as financial token, that could experience different things. Who knows, right? Overall, the good thing about crypto is that there is a good bit of transparency there. So I see a lot of interesting work being done on data sets related to cryptocurrencies. So that's a pretty good thing. But in terms of if you're, let's say, building a model to trade crypto and things like that, I'm not an expert on that front. You're on mute, Cheryl.
Okay, I'm sorry. So I think we have time for one more question. So coming from someone in our crowd today, if I am already a specialist in NLP, is there any value in exploring a different domain, for example, computer vision? Or is it better to dig deeper into the experience I already have?
So it's a very good question. And it could apply to some of the other folks here who are specialized in one thing. They're trying to figure out if they need to kind of dig deeper there or they need to add something else to their portfolio. So the answer to this question is it depends. So how good you are at NLP. So are you pretty good at, let's say, coming up with different algorithms, or good at retraining BERT and some of the other models out there like GPT-3 and things that you're good at using them and things like that. If that's the case, if you feel like you are going to contribute to that domain, it's better to dig deeper. But if you are a user of that domain and you know enough, and you are not being challenged anymore by the projects you're seeing, then I would actually say another field would be good. So computer vision in this case is a pretty good example, because they both rely on NLP, and computers rely on deep learning, so there is some synergy there.
Okay, so moving on, I think we have actually more time to see one more question. So coming from someone from our crowd again, I see the marriage of data science skills with solid MBA-enabled career experience as highly synergistic. What are your thoughts? Seems that many openings are stressing advanced computer science background over advanced business education and experience. Isn't the field wide enough for both?
I think it is. And one of the things I would say is that, so folks who are coming out of MBA program, I actually graduated from an MBA program. I think they would be probably better trained at telling stories and relating different things together. And having that as skill is going to be a pretty good complement to hardcore data science skills. I would say for anyone, not just for those who are graduating from MBA programs or other business-related programs, for anyone, having a good mix of hard skills and soft skills, that would be a pretty good and ideal type of background. So you know what you're doing when you're working on a model, but then when you are communicating the findings of your model to decision makers who may not be familiar with, let's say, the technical terminologies, that would require some soft skills, which would be something you can pick up in a business program.
Thank you so much. So it looks like we have covered most of your questions. Professor Mousavi, is there anything else you would like to add before we wrap up the discussion?
No, that's pretty much it. And thank you so much for having me. And I hope that it's been useful.
Thank you so much, everyone. So thank you, everyone. We appreciate you being here today. Thank you, Professor Mousavi, for sharing with us this wonderful discussion around AI jobs and the remote economy. So in this remote economy, Experfy is here to help you. If you are looking for part-time or full-time remote consulting jobs or projects in the field of AI and data science, sign up with Experfy and get one step closer to working with companies such as Deloitte, Vodafone, Mayo Clinic, and more on their mission-critical projects. If you are a hiring manager as well, looking to hire pre-vetted AI and data science talent, we are also here to help. So thank you everyone for joining today, and we'll see you on our next webinar. Thank you guys.